Hello and welcome to Fun with Flags. No, I'm just kidding. We're starting Trig. Yay, we're so excited. Trigonometry, finally here. Okay, today was a brief review of what you did last year. And then a little bit more. We're going to talk about sine, cosine, and tangent. And then we're also going to discuss... I got this. We're going to discuss the other trig functions. So trigonometry, as you may know or may not know, remember, is the study of triangles. Yay! Almost as good as flags, but not quite. Okay, so study of triangles. Now, more specifically, we are going to be discussing right triangles. So we do focus a lot on right triangles because there's a lot of cool things that happen with right triangles. Okay, the first thing is you have to know the three names of the sides of the triangles. Now, most of the time we think of them as sides and the hypotenuse. But when we start talking about an angle, like theta here, now that is angle theta, if you don't know what that means. So that little, it's like a little cursive O almost. T-H-E-T-A, and it's a Greek letter that we often use to represent angles. So once we start talking about the right angle and an angle inside the right triangle, we can discuss the opposite side over here, the adjacent, which is right next to it, and then the hypotenuse, which is across from the right angle. So those are the three basic parts. If you know the opposite, adjacent, and hypotenuse, then you can do all trig functions and it's pretty straightforward. Okay, so I'm going to ask you to try these. Now the problem with this is, one, you don't know where the right angle is, and two, you don't know what angle, okay, to start from. So I'm going to pick the obvious right angle. Okay, so for all of these, the obvious one is the right angle. I'm not going to be all tricky on you here. Oh, you didn't see that. So these are the obvious right angles. So hopefully from there, you can find the hypotenuse. The hypotenuse is always across from the right angle, or opposite it. So these two sides make the right angle, so the side opposite is the one side that doesn't. Okay, so this is the hypotenuse. Hypotenuse. All right. Now, for you can just put an H, which I will do for the rest of these, but all right. Then, in order to pick the opposite and the adjacent side, you need to know the angle you're referring to, because the opposite and the adjacent change depending on what angle you're at. So if I choose this angle, then adjacent is the one between the right angle and the angle we're talking about. So this is your adjacent. And then the opposite is the last one, or the one that's opposite. I know it's tough to remember. Okay, so if you don't know that angle, you don't know the sides, adjacent and opposite. So it's very important you recognize that. So if I change this up and I said, okay, now it's this angle, then this side would be the opposite here, and this would be the adjacent. I don't want to do that because I don't want to, I don't even know how to erase anymore. Okay, I'm just going to pretend that's done. All right, moving on to the next one. So you need to know what angle to start from. So I'm going to say, okay, choose that one, this one, and this one. And please write the O, A, and H. You can pause it and take a second to do it. I'm just going to put O, A, and H's on there because you paused it and we're back. Okay, so this is the H for hypotenuse, this is the O for opposite, and the A for adjacent. If you still have problems with that, ask your teacher in class. guess. So this is the right angle, so this is the hypotenuse across from it. Adjacent is always between the angle and the right angle. And the opposite is the third one. And then finally, hypotenuse I always do first, then I do adjacent, and then opposite. But obviously you could do whatever you want. Alrighty. So those were the first 3 trig ratios. You do need to know those by heart, and you are going to have to know the other 3 we're going to do in a minute. So the sine of theta here is how you say this. So it's the sine of theta. Whenever you're discussing sine, you always have to talk about it with an angle. If you don't, it doesn't make sense. So make sure you always have the angle present. In this case, we're doing sine of theta. So the first 3 trig ratios play into the fact that all triangles with the same angles are similar. So remember, they're in proportion. So the sine of any angle is always the opposite over the hypotenuse. And then this is just some number, which is a ratio in itself. So that's how that works out. So cosine of theta is adjacent over hypotenuse, and tangent is opposite over adjacent. Those are the 3 major trig ratios that we discuss. Okay? So if we're looking at this triangle right here, and I want you to find the sine, I got this. I would like you, please, to find the sine of A, cosine of A, and tangent of A. So, but I also want you to find the sine of B, cosine of B, and tangent of B. So when I say this, do the first ones with A first, please. Okay, so use this angle first, and then do the B, because the A and the O, the adjacent and the opposite, are going to change when you change the angle. So here's sine of A, so let's say that's the angle we're talking about. So hypotenuse will never change, that's going to stay H, but the adjacent is going to be here. I'm going to make it little a so it's not like that one. And opposite is here. So we simply do, okay, so the sine of A is equal to opposite over hypotenuse. So the opposite is a 4, and the hypotenuse is a 5. Done. We don't even have to find the angle. You may remember from last year we found you guys found angles. We're not doing that this year. So it's the cosine of A is adjacent over hypotenuse. So the adjacent is 3, the hypotenuse is 5, and the tangent of A is equal to opposite over adjacent, which is 4 over 3. That's how you do it. So then if you want to do B, I'm going to change B to be red because for some reason I can't erase. Okay, now that's B. For B now, this isn't opposite anymore, adjacent anymore. This is now the opposite. Between the angle and the right angle, it's now the adjacent. So now it just switches around a little. So the sine of B is opposite over hypotenuse, which is 3 over 5. Cosine of B is adjacent over hypotenuse, which is 4 over 5. And the tangent of B is opposite over adjacent, which is 3 over 4. You may see similarities here, like these guys are the same and those guys are the same. That's a cool thing, and we will get to it eventually. Okay, now what happens if you're not given actual sides? Two things can happen. You may have to use the Pythagorean Theorem to figure that out, but sometimes they just want it in terms of their sides. Now, this is just my time to tell you, if I'm talking about an angle, it's a capital letter. And if I'm talking about the side opposite, it's a lowercase letter. So if this is angle G here, this is angle G here, the side opposite is always lowercase g. I don't really know if you did that in geometry, but that's how we do it here. So this is actually triangle dog. Okay, anyway, it's triangle dog. So O is the angle, little o, or lowercase o, is the side opposite. So if we do the sine of O, so why don't you pause it and take a second, because I don't want this to be too long of a video. So pause it and see if you got your answers right. All right, hopefully you did those correctly. Just take a second, maybe pause, look at the answer, and we're going to move on. All right, so these are called, these three, and the way that we pronounce them are cosecant, secant, and cotangent, are the reciprocal functions. So when we say reciprocal, which basically just means we flip. So the reciprocal of sine would be 1 over sine or cosecant, and so on. So these are the abbreviations for them. CSC is cosecant, SEC is secant, and COT is cotangent. So we actually say them. So if I say it's not cot or cot of theta, it's the cotangent of theta. And this is the secant of theta, and this is the cosecant of theta. We don't like abbreviate what we say. Okay? And then basically if I ever do 1 over anything, so let's say I do 1 over a half, it's keep, remember, change, flip. So it'd be keep the same, change to multiplication, because this is a giant division sign, and then flip. So if I say 1 over 1/2, it just means I'm talking about 2. So using that idea, we don't really have to represent them like this, but you do have to know these. You must know these identities by heart. You do have to know that cosecant is 1 over sine, and sine is 1 over cosecant, and so on. Hopefully we'll play into those a little bit later. Okay, but since the 1 over thing just simply means you flip it, if you know that the sine of theta is opposite over hypotenuse, since cosecant is simply the flip or the reciprocal, it's the hypotenuse over opposite. That's it. So you know cosine is adjacent over hypotenuse, secant, you flip it. Tangent is opposite over adjacent, cotangent is adjacent over opposite. Okay, so that's it. You just have to know those and recognize them when you see them, or find them, as we're going to do right now. So over here for number 1, given the following triangle, find the values for all 6 trig ratios according to t. Now, since they're giving me 2 sides of a right triangle, I can find the third. So this is the time to remind you of how to find the third side of a right triangle. That's the Pythagorean Theorem. That's a P, just the Y connected to it. Pythagorean Theorem. Okay, it means the side of a right triangle plus the side of a right triangle is equal to the hypotenuse of the right triangle squared. The side squared plus the side squared equals the hypotenuse squared. And you simply set that up. The 2 sides are the opposite and the adjacent, but you don't really have to matter, because since you're adding, which one goes in which order. So it's simply 5 squared plus 12 squared equals h squared. So some people like to call it a squared plus b squared equals c squared, but letters change all the time, so it's always the hypotenuse is by itself over here. So 5 squared is 25, 12 squared is 144. That's our hypotenuse squared, and then this is 169, I think. Now, since we are talking about triangles, we don't even have to talk about the negative version of that, because you can't have a negative 13. So knowing this side is 13. I simply want to find all trig functions, all trig ratios, in terms of their sides, so according to t. So we always have to know where that angle is, so this is the angle we're talking about. So t is the angle, so that's the side opposite, that's the adjacent, and that's the hypotenuse. I always like to label them because I get very flighty and mess things up. So I need to find the sine of t, the cosine of t, and the tangent of t. But then I have to find the other ones. I like to do these first. So the sine of t is opposite over hypotenuse. The cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Pretty sure I'm right. Okay, so I know the sine of t, so then I can do the cosecant of t. Just flip them. Now you could always say, oh, it's the hypotenuse over the adjacent, hypotenuse over the opposite, but if you know what the sine is, just flip it, and now you know what the cosecant is. So it's really important that you know these two are kind of paired together. And if I know what the cosine is, then I know what the secant is. Just flip it. And if I know what the tangent is, I know what the cotangent is. Done. I found all of them according to t using finding all 6 trig ratios. All right, the next one, a little different, but the same idea. If they give you what the secant is, they tell you that the secant is 17 over 8, you want to find all 6. Now you're like, well, there's no triangle. I call this the hidden right triangle. Just what I call it. Okay? There is a right triangle there, because if you remember that the secant is the hypotenuse over the adjacent, that's 2 sides of a right triangle. Crazy, right? So just draw any random triangle. This is the one I'm drawing. I'm going to say this is theta, because that's where I like it. That's my right angle right here. Here's my theta. I'm just going to say this is the opposites, this is the adjacent, this is the hypotenuse. So if the hypotenuse is 17, I'm going to write it there. The adjacent is 8. I'm going to write it there. I have 2 sides of a right triangle. So then using the Pythagorean Theorem, I can find the opposite side and then all 6 trig ratios. So it's 17, the 2 sides, which I don't know what the opposite is, so I'll just call it O squared, plus 8 squared equals 17 squared. So remember, the hypotenuse is always by itself. Okay, and the other 2 sides get added together. So it's O squared, 64, equals 289. Subtract 64. And O squared equals 225. Take the square root, and O is 15. Now that I have that, pause it for a second and find all 6 trig ratios. All right, here they are. Please make note, I always have an angle here. Always, always. You can't just write tangent equals. It has to be tangent of the angle or whatever, secant of the angle. Now remember, when you finish here, that you, right here, realize that this one, I'm highlighting it, as you can tell, I'm coloring it in, should match this one up here. So that's 17 over 8, that's 17 over 8. We're good. Okay, have a great rest of break. Bye-bye.